Hello, Mr. Gabriel. Good to see you again. I hope you are doing well. Actually, so far we have 3 classes related to or regarding about polynomials. It's the second part of polynomials. And in this actual video series, we talk about the definition of a polynomial, how to divide a polynomial by another polynomial, right? And the factor theorem and the remainder theorem. And we just saw a few questions related to polynomials. So that is the last part of this class. So today we are going to solve questions in the given test. Okay, in the test, I think we have around 8 and 13, 15, 17 questions. We will see as much as we can. Okay. So during the class time, if you have any questions, you can just raise your hands so I can see. All right. And I'll try to answer your question. So let's start now. I assume that actually you have enough knowledge about what we mean by quotient and remainder, dividing a polynomial by another polynomial. So that's why now we are just practicing these questions to consolidate our knowledge on this topic. So the first 5 questions are similar questions. And the first one, it says, find the quotient and remainder of. Okay. So here we are just going to use the long division methods. That is easy and practical. Maybe other methods also fine, but long division, you don't have to memorize anything. You have to just know the idea and you can just apply this. So to do this one, here we're going to divide this 2x cubed plus 7x squared minus 11x plus 8. Okay, some people write this in different way, but I'm going to just write in this way. So here we have dividend. Our divisor is this, x squared minus 3x plus 2, right? So we're going to actually carry out this division. As you know, just from the term which has the highest power. Of course, before you do this one, actually you need to write these polynomials in standard form. Standard form means in descending order their powers, right, or the degree of x. So anyway, 2x cubed is divided by x squared. That's equal to 2x. 2x times x squared, that is 2x cubed. And 2x times minus 3x minus 6x squared. 2x times plus 2, that is plus 4. Now, if you subtract this, draw a line here, 2x cubed minus 2x cubed. Now, see here, step by step, we are eliminating the highest power polynomial. And 7 minus 6, that is 13x squared. Negative 11 minus 4, that is negative 15x. And so here we have 8. So now we are just applying the same process. Now we have to divide the 13x squared minus 15x plus 8 by x squared minus 3x plus 2. You see here the degree of 13x squared is greater than or equal to the degree of x squared. That means that we can continue our division. So 13x squared is divided by x squared. That's equal to positive 13. 13 times x squared, that is 13x squared minus 39x plus 26. And if you just subtract this, here we have 0, negative 15 minus 39, that's equal to 24x, and 8 minus 26, that's equal to 18, right? So now the degree of this polynomial is equal to 1, right? The divisor's degree is 2. So we cannot continue anymore. What is the question here? The quotient and remainder. So this one is the quotient. And this one is the remainder. Another example, find the quotient and remainder of this. Again, everything, just have a look first. Everything is written. All the polynomials are written in the standard form, just so we have to carry out division. 3x cubed minus 2x squared minus 4x plus 3. Is divided by, here we have x squared minus 2x minus 1. So, all right, let me just use green. 3x cubed is divided by x squared, that is 3x. 3x times x squared, that is 3x x cubed, and 3x times minus 2x minus 6x squared, 3x times negative 1 minus 3x. Now subtract here, draw a line, 3x cubed minus 3x squared, that is 0, minus 2x squared minus 6x squared, that is 4x squared, minus 4x minus 3x, that is minus x plus 3. And 4x squared is divided by x squared, that's equal to 4. 4 times x squared, 4x squared, and minus 8x minus 4. And now if you just subtract this, 4x squared minus 4x squared, that's 0, minus x minus x, that is 7x, 3 minus 4, that is 7. So now we can write the result here. The quotient, let me just label this by Q, that is 3x plus 4. And how about the remainder? Remainder is 7x plus 7. Okay. So that means our px, actually, we can just write it as, you know, it is divisor, right? Times quotient. And here we have the remainder. So that means if you multiply x squared minus 2x minus 1 by 3x plus 4, and after that add 7x plus 7 to the result, we will get our original polynomial. Okay. Another question, find the quotient and remainder of this. Okay, so all the polynomials are written in standard form. So we'll just start carrying out our division then. So here we have 10x to the power of 4 plus 14x cubed minus 27x squared minus 21x plus 23. And that is divided by 2x squared plus 2x minus 3. Okay. So first, 10x to the power of 4 is divided by 2x squared. That is 10 over 2, it is 5. X to the power of 4 over x squared, that is x squared. Multiply back, here we have 10x to the power of 4 plus 5 times 2, it is 10x cubed, and 5 times 3 minus 15x squared. Subtract. So here we have 0, 14 minus 10, it is 4x cubed, minus 27 minus 15, minus 12x squared, minus 21x plus 23. Now 4x cubed is divided by 2x squared, that's equal to plus, what is it? It is 2x. 2x times 2x squared, that is 4x cubed. And here we have plus 4x squared. 2x times negative 3 minus 6x. And just subtract here. It is 0, minus 12, minus 4, minus 16x squared. And minus 21 minus 6. It is again minus 15x plus 23. So the degree of the remainder here is 2. The divisor's degree is 2. Still, we can continue our division then. Minus 16x squared is divided by 2x squared. Okay, Galvin, let's see. So minus 16x squared is divided by 2x squared, that's equal to minus 8. Minus 8 times 2x squared minus 16x squared, and minus 16x plus 24. So if you subtract, is equal to 0, minus 15 minus 16, it is x, 23 minus 24, that's equal to minus 1. So now we cannot continue because the degree of the remainder is always less than the degree of the divisor. We should stop here then. This is our remainder. That is a remainder. Okay, so this is our quotient. Find the quotient and remainder. 3x to the power of 5 plus 7x to the power of 4 minus 12 times x cubed minus 5x squared plus 11x plus 13 is divided by x squared minus 3. Okay, again, since the divisor is not a linear, so we better use the long division method. So here we have 3x to the power of 5 plus 7x to the power of 4 minus 12x cubed minus 5x squared plus 11x plus 30. And that is divided by x squared minus 3. 3x cubed to the power of 5 is divided by 3x squared, that is 3x cubed. And 3x cubed times x squared, that is 3x to the power of 5 and minus 3x to the power of 4. So here it is cubed. Let me just write it here. It is here we have minus 3x cubed minus, so if you subtract here 3x to the power of 5 minus 3x to the power of 5, that's equal to 0. And 7x to the power of 4, we don't have anything here. So here we have 7x to the power of 4 minus 12 minus 3. It is minus 9x cubed. And here we have minus 5x squared plus 11x plus 30. So now 7x to the power of 4 is divided by x squared, that is plus 7x squared. So 7x squared times x squared, 7x to the power of 4. And here we have minus 21, actually not, again, let me just write here, minus 21x squared, because we don't have x cubed here. Not to get confused, I'm just writing under this x squared. So 7x to the power of 4 minus 7x to the power of 4, that's 0. And here we have minus 9x cubed minus 5 minus 21 plus 16x squared and plus 11x plus 30. So minus 9x cubed is divided by x squared, that is minus 9x. Minus 9x times x squared minus 9x cubed, and the plus, again, here, let me just write here 27x, that's it. So if you subtract, that's 0, right? That is, here we have 16x squared and the minus 16x plus 13. Still we can divide this. 16x squared is divided by x squared, that's equal to, just move it here. Okay, minus 9x, right? That's equal to, what is it? That is plus 16. And 16 times x squared, 16x squared. And the minus, actually it is minus 48. Now if you subtract, here we have minus 16x and 13 minus 48, that's equal to 61. So now we cannot continue this division, right? So that's why this is the remainder. I can just write here. Actually, this is the quotient. Let me just write here. This one is the quotient. That's equal to quotient. And the remainder is equal to minus 16x plus 61. Okay. Another example, that's the last actual example. The questions are a little different. So again, find the quotient and remainder of this. So 9x, here we have 9x to the power of 5. It is 5. Okay, I think it's not a long here. 3x to the power of 4 minus 12x squared minus 4x plus 15 is divided by 3x cubed plus 2x minus 3. So 9x to the power of 5 is divided by 3x cubed, that is 3x squared. Multiply by x, so it is 9x to the power of 5. 3x squared times 2x, that is plus 6x cubed. Unfortunately, we don't have x cubed, but what can I do here? Anyway, let me just write this 6x cubed. And here we have minus 9x squared. So you should be careful, actually, x to the power of 4x cubed, they are not the same. So if you subtract here, 9x to the power of 5 minus 9x to the power of 5 is 0. So minus 3x to the power of 4. So I'm going to write here minus 3x to the power of 4. And here we have minus 6x cubed because they don't have pair. And minus 12x squared minus 9x squared. That is minus 3x squared minus 4x plus 15. So now minus 3x to the power of 4 is divided by 3x cubed. That is minus x. So minus x times 3x cubed, that is minus 3x to the power of 4. And here we have minus, what is it, 2x squared. Again, here we have minus 2x squared. Also here we have minus 3x, minus plus 3x. Because minus x times minus 3 is plus 3. So that's 0. So here we have minus 6x cubed. Minus 3 minus 2x squared, that's just minus x squared, minus 4x minus 3x minus 7x plus, here we have 15. And 6x cubed is divided by 3x cubed, that's equal to minus 2. 2 times 3, that is minus 6x cubed, and the minus 4x plus 6. Anyway, so if you just subtract here the 0, here we have minus x squared, minus 7x minus 4x, it is minus 3x, 15 minus 6, that's equal to 9. So now the degree of the remainder is less than 3, so we cannot continue division anymore. So actually that is the remainder. And this one is the quotient. Okay, find the remainder of dividing this by this. So here in this kind of questions now, we are going to use the remainder theorem, right? And since suppose that this is our polynomial, let's say this p of x, and this one is the divisor, that is d of x, right? So this polynomial p of x, we can write it as d of x times the quotient, and the remainder, actually our divisor is of degree of 1. So which means the reminder's degree should be less than 1, which is only 0. So here we have just a constant number. That's the remainder, that's constant number. And that's why, since here actually our divisor x minus 5, so here we have p of x, I can write it as x minus 5 times q of x and plus remainder. Right? And see here, if x is equal to 5, this q of x disappears from the equation, only remainder is left on the right-hand side. So now we are going to use the remainder theorem here. So from here, the remainder is equal to p of, what is it? It is 5. Because when x equals 5, qx will disappear, only remains left on the right-hand side. So simply we have to evaluate the value of our polynomial function at x equals 5. So that is 5 to the power of 4 minus 3 times 5 cubed plus 5 times 5 squared plus 9 times 5 minus 1. Okay. So here, actually, here we have, what is it? 5 to the power of 4 means 5 times 5 cubed and 3 times 5 cubed. So that's equal to 2 times 5 cubed. And plus, and here we have 5 times 5 squared, that is 5 cubed plus 45 minus, okay, 45 minus 1 is, here we have 44. And 2 5 cubed, here we have one more 5 cubed. 5 cubed is 125, and 3 times 125, it is 375. And 375 plus 44, 375 plus 44, that's equal to, what is it, 409. So dot, 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 if you just divide this, the remainder will be 419. Another question, find the remainder of dividing this. So simply now you know the idea. I'm going to just find the remainder here. So the remainder is equal to p of, when this linear factor is equal to 0, when x equals 1/2. So here we have 1/2. So value of this polynomial function at x equals 1 over 2 gives us remainder. Once again, why? Because our divisor is a linear factor here. So here we have 2 times 1 over 2 cubed minus 5 times 1 over 2 squared and minus 8, which is equal to, the first one is 1 over 8 times 2, that is 1 over 4, minus second one is 5 over 4 minus 8, and 1 minus 5 is negative 4, over 4 is negative 1, negative 1 minus 8, that's equal to negative 9. So dot, 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 the remainder of dividing this polynomial by 2x minus 1 is, what is it? It is negative 9. Find the remainder of dividing x to the power of 5 minus 2x cubed plus 10x squared minus 6 by x plus 1. Again, since our divisor is linear factor, so simply we can just find the remainder using the remainder theorem. That's equal to p of negative 1. So which means that negative 1 to the power of 5 minus 2 times negative 1 cubed plus 10 times negative 1 squared minus 6. Which is equal to negative 1 to the power of 5, that is negative 1, minus 2, negative 1 to the power of 3 is negative 1, negative 2 times negative 1, that is positive 2, and here we have positive 10 minus 6. So that's equal to 12 minus 7, that's equal to 5. Dot, 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 so our remainder is, what is it? It is 5. Okay, now let's solve a few questions from part B. Given that k squared plus 2k equals 2 is equal to 2. Find the value of k to the power of 4 plus 4k cubed plus 5k squared plus 2k plus 2008. So one way is, okay, number one, I just want to draw your attention to this solution. So since k squared plus 2k is equal to 1, if you just add 1 to both sides, what do we have here? Here we have k squared plus 2k. Okay, here we have k plus 1. Okay, I think I better change all this k squared by 2. K squared. Okay. All right, I think I better keep this like this. 1 by k. All right, so let's continue then. So let's say we're going to find the value of that thing. So that thing is equal to, let's say it is a. Here we have k to the power of 4. Okay, I can just write it as k squared. That's k squared squared. Let me just write substitute, okay, immediately. So that's in this way we can reduce the power of k's. K to the power of 4, I can write it as k squared squared. So what is k squared? K squared is equal to 2 minus 2k. And here we have squared. Plus 4k cubed, we can write it as 4 times k squared. K squared is equal to 2 times 2k. And plus 5 times, what is k squared? It is 2 minus 2k. And here we have 2k plus 2008. Okay. So now if we just actually expand these things, what do we have here? Here we have 4 minus 2 times 2, 4. So here we have 8k plus 4k squared. Plus 4k times 2, it is 8k minus 8k squared. Next one is here we have 10 minus 10k plus 2k plus 2008 equals, now let's just simplify, okay. Here we have this 8k and minus 8k plus 8k, they are gone. And okay, so, and also here we have, what is it, 4k squared minus 8k squared. So we can write here as, what is it, minus 4k squared. Okay, now also they are gone. And here we have minus 10k plus 2k, that is minus 8k, right? And here we have 4 plus 10, it is 14, and 14 plus 2008, that's equal to plus 2022. Okay, so now here, right, The negative 4 is a common factor. Just take this out. So here we have k squared plus 2k. And here we have 2022. And what is k squared plus 2k? Again, that's equal to, what is it? It is 2. So here we have negative 4 times 2 plus, actually here we have 2022. And if you subtract 8, right, that's equal to 2014. So the result of that expression is 2014. Another question, the remainder of dividing x cubed minus 5x squared plus kx minus 3 by x plus 2 is negative 39. Find the value of k. Okay, what does it mean? It means that here we have, let's say, the solution. So let's say our polynomial function is x cubed minus 5x squared plus kx minus 3. And you are dividing this by x plus 2, right? And here we have the quotient. We are not interested in this. The remainder is negative 39. The question is, we need to find the value of k. So now if you substitute negative 2 for x, y, as here, this q will disappear because that's unknown. I don't want to keep this in my equation. So now let's substitute negative 2 for 2, for x, negative 2 cubed minus 5 times negative 2 squared plus k times negative 2 minus 3. On the right hand side, negative 2 plus 2 is 0. So here we have negative 39. Now negative 2 cubed is negative 8. And negative 5 times 4, that is negative 20. And here we have negative 2k minus 3 is equal to minus 39. Well, what is 2k? 2k is equal to minus 39, minus 8, minus 20, minus 28, minus 28, minus 31. Take to the right-hand side, it is plus 31. So k is equal to negative 39 plus 31, that is negative 8 over negative 2, which is equal to 4. So the value of k is 4. Question 3. The remainder of dividing 2x to the power of 4 plus 3x cubed plus ax plus b by x minus 1 is, and x plus 2 are 3 and 21 respectively. So that means that if you divide it by x minus 1, the remainder is 3. If you divide it by 21, the remainder is 21. X plus 2. What does it mean? It means that we can just write here in two equations. So here we have 2x to the power of 4 plus 3x cubed and plus ax plus b is equal to, if you divide it by x minus 1, the quotient is q1 of x. And here the remainder is 3. Now the same thing, right? If you just divide this by x plus 2, the quotient is q2 of x. The remainder is 21. Gabriel, let's have break for 3 minutes, okay? Then we will continue. All right, let's continue. So also on the right-hand side, actually, we have the same thing. Even I can anyway, so we have two equations. Now to continue this, see the first one, actually, if you substitute 1 for x, right, the q1 disappears from the equation. We will have only equation in a and b. So if you substitute 1, here we have 2 times 1 to the power of 4 is 2 plus 3 plus a plus b. On the right-hand side, we have just the remainder, this 3. And if you substitute in the second one, negative 2, right? So negative 2 is 2 times negative 2 to the power of 4, that is 16. Minus 3 times negative 2 cubed, that's 8. That's why I write here minus 8, 3, 8. And here we have minus 2a plus b. On the right-hand side, we have 21. Now here we have just, what is it? Simultaneous linear equations in two unknowns, right? The first one is, we can simplify this to a plus b is equal to negative 2, because 3 is 3, right? They cancel each other, take it to the right-hand side. And how about the second one? Negative 2a plus b is equal to 2 times 16, that is 32. 32 minus 24, that's equal to 8. Take 8 to the right-hand side, 21 minus 8, that's equal to 13. Now, if you just subtract the second equation from the first one, a minus minus 2a, that is 3a, negative 2 minus 13, that is minus 15. So from here, what is a? A equals negative 5. And if you just substitute the first equation, negative 5 plus, what is it? Negative 5 plus b is equal to negative 2. So what is b? B is equal to 3, because negative 5 plus 3 equals negative 2. So dot, 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 then a is equal to negative 5 and b is equal to 3. Okay, question 4. Given that x squared minus 4 is a factor of this polynomial function, x to the power of 4 plus x cubed minus x squared plus ax plus b. Find the values of a and b. It's also similar question to the previous one. So that means that here we have x to the power of 4 plus x cubed minus x squared plus ax plus b, that's equal to x squared minus 4, right? This x squared minus 4, we can factorize it as x minus 2 and x plus 2. So if you divide this by this, here we have some quotient, right? And it says a factor, that's why the remainder is equal to 0. Again, as you see here, this x squared minus 4 is equal to 0 when x equals 2 or negative 2. So if x equals 2, here we have 2 to the power of 4 plus 2 cubed. Here we have 2 cubed and minus 2 squared plus 2a plus b. On the right-hand side is equal to 0. And how about if it's negative 2? Here we have negative 2 to the power of 4 plus negative 2 cubed minus negative 2 squared minus 2a plus b is equal to 0. Right. And if you simplify the first equation, on the left-hand side, we have 2a plus b. On the right-hand side, 16 plus 8, 24. 24 minus 4, it is 20. So take to the right-hand side, it is negative 20. And the second one, it is 16 minus 8, it is 8. 8 minus 4, it is 4. Take to the right-hand side, so here we have minus 2a plus 4 is equal to 16. 8, it is 4, so that's equal to minus 4. Again, a similar way, if you just subtract actually the second equation from the first one, 2a minus 2a, that's equal to 4a. Minus 20 minus minus 4 minus 16. So what is a? A equals negative 4. If a is equal to negative 4, it is 8, right? So b is equal to negative 12. So these are the answers. I mean, this is how we actually solve questions related to factor theorem and the remainder theorem. All right, next question, question 5. Given that a minus b is equal to 2 and a times b is equal to negative 4, find the value of a cubed minus b cubed. How you find this? Actually, we are just going to use some identities here. Okay. Number one is, so since we have to find a cubed minus b cubed, and a cubed minus b cubed, yeah, we know that it's equal to a minus b times a squared plus ab plus b squared, right? And also I can continue. I can just write this one as, I mean, in terms of a minus b and ab. How? Equals, okay, here we have a minus b, right? And this a squared, if I just add ab and subtract ab, here we have a squared minus 2ab plus b squared. Now I'm just adding minus 3ab and subtracting 3ab, right? So minus 3ab plus ab is minus 2ab, and plus here we have 3ab. And see here, minus 2ab plus 3ab is equal to just ab. Now, what is this? It's just a perfect square, right? So now we can write it as a minus b, and here we have a minus b squared plus 3ab. It's called algebraic manipulation. We're just manipulating the given variables. Equals, what is a minus b? Let me just substitute here now. A minus b is equal to 2 times, here we have 2 squared plus 3 times, what is ab? It is negative 4. So that's equal to 2 times 4 minus 12. That's equal to minus 8. So the answer is minus 16. Okay. Dot, dot, dot. The value of a cubed minus b cubed, that's equal to minus 16. Okay, now here we have part C. We have 2 questions here. It says that 10 marks each, total 20 marks, given x minus 1, x plus 1, and 2x plus 1 are factors of 6x to the power of 4 plus ax cubed minus 14x squared plus bx plus c. Find the values of a, b, and c. So again, we're going to use the similar methods. And it says that, so this 6x to the power of 4 plus ax cubed minus 14x squared plus bx, just write b nicely. Here we have bx plus c, right? Just right here. If you divide it by x minus 1, and here we have the quotient, right? And the remainder is, it's a factor. That's why we don't, remainder is equal to 0. And if you divide it by x plus 1, the quotient is, let's say there's something here, we don't need it. And if you divide it by 2x plus 1 again, and we have just quotient. That means that that polynomial can be written in these forms. That's what we mean by the factors, right? As a single thing, also I can write it like x minus 1 times x plus 1 times 2x plus 1 times q. Also, it's fine, okay? And also I can write in different ways, fine. So now what does it mean? It means that if x equals 1, the value of the polynomial should be equal to 0. If x equals negative 1, the same thing should be equal to 0. If x equals negative 1 over 2, the value of the polynomial should be equal to 0. So now if you just substitute one by one, so here the first one, if x equals 1, if x equals 1, right? So here we have 6 plus a minus 14 plus b plus c is equal to 0. And if x equals negative 1, if x equals negative 1, again, it should be equal to 0. 6 times negative 1 to the power of 4, that is 6. And here we have x cubed, right? That's minus 1 cubed, that is minus a. And here we have minus 14 minus b plus c is equal to 0. And how about the third one? How about if x equals negative 1 over 2? It is equal to negative 1 over 2. Here we have 6, x to the power of 4, 2 to the power of 4, that is 16. Plus, here we have a over x cubed, that is 8. Because it's minus 1 over 2, so it should be minus 1 over 8. And minus 14 x squared, so that's 1 over 4. Here we have 4. And minus bx, that is b over 2 plus c is equal to 0. Okay, so let's just give some speed. Let me just write it as this, the single expression. So that one is, what is it? X minus 1, x plus 1, 2x plus 1 times q of x. Okay. Now from here, let's simplify this fraction expressions, equations, and from the first one, what is a plus b plus c? A plus B plus C is equal to 6 minus 14 is minus 8. Take to the right hand side is equal to 8. The second one, minus A minus B plus C is equal to, and 6 minus 14 minus 8, take to the right hand side, again is equal to 8. Right, and the third one, here we have minus A over 8, minus A over 8. Before I continue, let me multiply both sides by, what is it, 8. Okay, if you multiply by 8, actually this 6 over 16 is, what is it, 3 over 8. So here we have 3 minus, here we have A minus, and this one is 8, okay, 2 times 24, here we have 28 minus 8 times 1 over 2, 4, so here we have 4B plus 8C is equal to 0. So what we have here, minus A minus 4B and plus 8C is equal to 3 minus 28, that's equal to 25. Take to the right hand side, it is 25. So we need to solve this 3 simultaneous equations. Okay, from the first one, let's see here, if you just add these two, what we have here, if you add these two, A plus negative 8, 0, B plus negative B, 0, from here 2C is equal to 8. So now we know C now. What is C? C is equal to 4. No. If you add them, 2C, 8 plus 8 is 16, so C is equal to 8. Okay. So which means that now if I simplify this from the first equation, A plus B then should be equal to 0, right? Because C is equal to 8. The second one, the third one, minus A minus 4B should be equal to, C is equal to 8. 8 times 8 is 64. 25 minus 64 is equal to, what is it? Minus 49. No, 39. Right. So now, again, if we just add them together, here we have minus 3B, because A plus minus is 0. So that's equal to minus 39. What is B? B is equal to 13. So if B is equal to 13, what is A? A should be equal to minus 13, because A plus B is equal to 0. Okay, so dot, 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 we can write the final answers here. Dot, dot, dot. A is equal to minus 13, B is equal to 13, and C is equal to 8. All right. Question 2, prove that 3x minus 4 is a factor of 6x to the power of 4 minus 11x cubed plus 19x squared minus 26x plus 8 by the factor theorem. Okay, so what we mean by this, by factor theorem, that means that since we are claiming that this 3x minus 4 is a factor, right? So suppose that this polynomial function, okay, let me just label this by p of x. So that means that this p of x should be equal to, when you divide this by 3x minus 4, the remainder should be equal to 0, no remainder. So which means that using a factor theorem, that I have to show that if p of 4 over 3 is equal to 0, it is done. That means that actually we don't have remainder, right? Remainder is equal to 0. So which means that 3x minus 4 is equal to, 3x minus 4 is a factor of this thing. So now let's actually show that p of 4 over 3 is equal to 0. So the first one is 6 times 4 over 3. And here we have to the power of 4 minus 11 times 4 over 3. And here we have cube plus 19 times 4 over 3. And it is squared minus 26 times 4 over 3 and plus 8. Okay. So now from the first one, how can I simplify this? 4 over 3 cubed is a common factor. If I just take this out, I can actually simplify this a little bit more. Okay, 4 over 3 cubed, right? From the first two, this cube is common factor. What's left inside? Here we have 6 times 4 over 3 minus 11. And plus, how about this one? I have nothing to do here. 19 times 4 over 3 squared plus this one is 26 times 4 over 3 minus and plus 8. So 6 times 6 over 3, it is 2. 2 times 4 is 8. 8 minus 11, it is minus 3. So here we have just minus 3 times, okay. Again, this one is, all right, I think I should just write this one, minus 3. So here we have minus 3 times 4 cubed over 3 cubed. Plus, next one is 19 times 4 squared over 3 squared. Minus, this one is 26 times 4 over 3 and plus 8. Now, actually, this 3 cancel each other, right? So the first one is, here we have minus 4 cubed, that is 64. And the plus 19 times 16. What is 19 times 16? 19 times 16 is, it is 304. And 304. And minus 26 times 4. So here we have 26 times 4 times 3. That's 26 times 4 times 3. That's equal to 312. Plus 8 times, here we have 9 because common denominator is 9. 8 times 9 is just 72. And here we have the common denominator of, what is it? 9 squared. That it's 3 squared. That's 9. So now if you simplify this, 304 minus 312, that's minus 8. Minus 8 plus minus 64 minus 72. So that's equal to then 0 over 9, which is equal to 0. So that means that from here, we can draw a conclusion that then 3x minus 4 is a factor of P of x. Why? Because P of 4 over 3 is equal to 0. All right. And we have 2 more questions in additional questions parts. Prove the identity x plus y squared plus y plus z squared plus z plus x squared minus x squared minus y squared minus z squared. Okay, as you remember, actually, to prove identities from left-hand side, we had to show that we can obtain right-hand side. Or a lot of things, actually. Here, I'm just going to use that method, okay, from left-hand side, and I'm going to obtain right-hand side. Okay, how do we do that? Now, if you just actually solution here, left-hand side is equal to, if we just expand this, here we have x squared plus 2xy plus y squared. And here we have y squared plus 2yz plus z squared. And here we have z squared plus 2zx plus z squared, right? And here we have minus x squared minus y squared minus z squared. So equals, now from here, x squared and x squared, they are gone, and y squared and y squared, they are gone, and z squared and z squared, they are gone. So now if we just regroup this, what we have here? Here I have y squared, right? X squared, y squared, z squared. Okay, the last one is actually this x squared. It's not z squared. This x squared. So I have 1x squared. Let me just write step by step. X squared. I have 2xy here plus 2xy, and plus we have y squared here, y squared. And after that, okay. After that, here we have 2yz. Let me actually, I better write like this. First, the squares of a single variable. Here we have x squared and y squared and plus z squared, right? And after that, here we have 2xy plus, and here we have 2yz plus 2zx. Right? Now, if you remember, actually, it's just, what is it? The square of these things, x plus y plus z squared, right? Because if you just square this, we will get that thing, because x plus y plus z squared means x plus y plus z squared means that's equal to x plus y plus z. Also in different way, actually, I can expand this, x plus y plus z. X times x, x squared, x times y, xy, and y times x, xy we have 2. X times z, zx we have 2, right? And also y times y, y squared, z times z squared, and the combination, so we will get a thing. So that's equal to x plus y plus z squared, which is equal to right hand side. Hence, actually, this identity is proved. Okay, we have the last question. Suppose f of x is equal to 2x to the power of 4 plus x cubed plus 10x squared plus 2x plus 15, and g of x equals x cubed plus 2x minus 3. The question is find f and g. What is it? F and g. In the note at the bottom, actually, f and g means here we mean the highest common factor of f and g. Okay. Again, when we talk about numbers, we know how to find the highest common factor, right? In polynomials, what do we mean by highest common factor? We mean that actually it is a factor which has the highest degree. Okay, so to do this one first, we will start with x cubed. Okay, what are the factors of x cubed? And after that, I will find what factors of g divides or are also a factor of or factors of f of x. So now from here, first, let's start with finding the factors of g. So as you see here, g of x first, how do you find the factors of cubic polynomial? Plus, here we have 2x minus 3. One way is we need to guess a number. Okay, we need to define one linear factor. But if you notice here, it's easy to see that g of 1, that's equal to 1 cubed is 1, plus 2 minus 3 is equal to 0. So which means that actually this x minus 1 is a factor. So now I can find another factor. How can I find this? If you divide it by x minus 1, here we have x cubed plus 2x minus 3. And let's divide this by x minus 1. So here we have x squared, x cubed minus x squared, subtract, that's equal to 0. Here we have x squared plus 2x minus 3. Again, divide by x. Here we have x times x, x squared minus x. Subtract, it is 0. Here we have 3x minus 3. And divided, it is plus 3 times x. 3x minus 3 is equal to 0. So actually, this is a factor, right? So that means that now this one, I can write it as x minus 1 and x squared plus x plus 3. Okay. So now this x squared plus x plus 3, we cannot factorize it because if you find a discriminant that's less than 0, right? And we cannot factorize this. So that means that since it has this x cubed plus 2x minus 3, it has two factors, x minus 1 and x squared plus 2x plus 3, right? So we immediately also, if you check here, all right, this is the first step of our solution. The second step is, from the second step is, what is f of 1? F of 1 is equal to, it is 2 plus 1 plus 10 plus 2 plus 15. That's not equal to 0, right? So which means that x minus 1 is not a factor. Okay, I'm sure about this. So x minus 1 cannot be a common factor. Since we are talking about the highest common factor, then I will check x squared plus x plus 3 is it a factor or not. To do this one immediately with long division, let's divide this. Here we have 2x to the power of 4 plus x cubed plus 10x squared plus 2x plus 15. And if you divide this by x squared plus x plus 3. Right, here we have 2x squared. So here we have 2x to the power of 4. Let me use different color to the difference. Okay, which one? Use not blue, use black. So here we have 2x squared. So here we have 2x to the power of 4 plus 2x cubed plus 6x squared. So if you subtract here, that's equal to 0, x cubed minus 2x cubed, that is minus x cubed, and 10x squared minus 6x squared, it is 4x squared plus 2x plus 15. Now x cubed minus x cubed is divided by minus x squared, that is minus x. So here we have minus x cubed and the minus x squared minus 3x. Again, if you subtract, that's equal to 0, 4 minus minus 1, that is 5x squared, 2 minus minus 3 plus 5x plus 15. And 5x squared is divided by x squared, it is plus 5. Here we have 5x squared and plus 5x plus 15, which is equal to, if you subtract, this is the same expression, this is equal to 0. So what does it mean? So this 2x squared minus x plus 5, right? And that means that this x squared plus x plus 3 remains equal to 0. So that's also a factor. So this is a factor of f, this is a factor of g, which means that the highest common factor of these two polynomials is x squared plus 2x plus 3. So now we just write here dot, 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 the highest common factor of f and g is equal to x squared plus x plus 3. Gabriel, thank you very much. That's it for today. Okay, I wish we could actually learn more about each other, know about each other, and that's it. Okay, I wish you good luck in your studies, and if you're going to participate in Math Olympiad, I hope you will get a good result. Okay, thank you very much. Bye bye.